So far we have seen uh, linear equation. What is a linear equation? A linear equation in one variable and a linear equation in two variable. Okay. So now let us move on to solving linear equations. So consider the linear equation 3x plus 4 equals 13. So we have an algebraic expression on left side, an algebraic expression on the right side, and these two are related by the equal to sign. Okay, so this statement is a linear equation. Why is it a linear equation? Because both on the right side and the left side, the highest degree, okay, the highest degree of the variable or the expressions are linear terms. The highest power of the variables is 1. Okay, so this is a linear equation. So the solution of a linear equation is not affected when the same number is added or subtracted from both sides of the equation. So if you add or subtract the same number from both sides of the equation, it does not affect the solution of the equation. So I subtract 4 from both sides. So 4 minus 4 would be 0, 13 minus 4 would be 9. Also, if we multiply or divide the same non-zero number, if we multiply or divide the same non-zero number on both sides of the equation, that also does not affect the solution of the equation. So I divide both sides of the equation by 3. 3 by 3 would be 1 and 9 by 3 would be 3. So x is equal to 3. And we can solve a linear equation using these two rules. Okay, so moving ahead, so the solution of an equation is also called the root of the equation. So for the equation 3x plus 4 equals 13, okay, x is equal to 3 is a root of the equation. So the solution to the above linear equation in one variable, it can be represented on the number line as a point on the number line. So x is equal to 3 is the root of the equation, and if I take the number line, I can represent the root as a point on the number line. So x is equal to 3 can be represented as a point on the number line. Another thing about a linear equation and the solution of a linear equation in one variable is that this solution is unique. So if we try to fit in any other value for x, this equation won't hold true. Suppose if I take 5 and instead of x I put 5, I'll get 3x would be 15 plus 4. 19 is equal to 30, which is not correct, which is false. So a linear equation in one variable has a unique solution. So there is only one particular value of x for which if I substitute that value, this equation will hold true. So a linear equation in one variable has a unique solution. Okay, so now let us go back to the cricket match wala example. So now let us look at the solution of a linear equation in two variables. Okay, so earlier we saw how we are solving a linear equation in one variable. So now we will be interested in looking at solving linear equation in two variables. Okay, so there is a cricket match happening between India and Pakistan, and Virat Kohli and Hardik Pandya, they together made a partnership of 78 runs. Okay, so partnership means this person would be contributing his runs, and the second batsman would be contributing his runs, and together they have made 78 runs. Represent this situation in the form of a linear equation and solve it. Okay, so let k, small k, the variable, be the runs scored by Virat Kohli, and small p, okay, variable, be the runs scored by Pandya. So we have seen they together made 78 runs. That is, there was a partnership of 78 runs. So together means if we add both of their runs together, we get 78. So if K runs was made by Kohli and P runs was made by Pandya, when you add both of their runs together, what do we get? We get 78. So K plus P equals 78 is the required linear equation to the above situation. So now let us look at how do we solve this equation. So we have K plus P equals 78. So we are supposing we do not know what is K and what is P. So if K is 0, then K will become 0, then P is 78. So, so the solution of a linear equation in two variables is expressed in the form of a ordered pair, okay, where the first value is the value of the first variable and the second value is the value of the second variable. Okay, so here 0 comma 78, here 0 stands for the K value and 78 stands for the P value. So this group or this combination is a solution of the equation. How do we say it is a solution? If we substitute in place of K 0 and in place of P 78, this equation holds true. So for a linear equation in two variables, okay, the solution is represented as a pair, as an ordered pair. Okay, so now if okay, so the solution of a linear equation is an ordered pair x comma y. So where the first value is that of the first variable and the second value is that of the second variable. So so in the first solution we assumed, we are not sure, we're just saying if K is 0 then P is 78. So what if K is 1? If K is 1, then we have 1 plus P is 78 and we subtract 1 on both sides, we get P is equal to 77. So if K is 1, then P is 77. So 1 comma 77 is also a solution to the equation. So Virat Kohli might have made 1 run and Hardik Pandya might have made 77 runs. We don't know. All we know is together they have made 78 runs. And in this case, this is also true. This is also true. Okay. So 1 comma 77 is also a solution to the equation. So a linear equation in two variables does not have a unique solution, unlike the linear equation in one variable. Because a linear equation in one variable, uh, there was only a particular value for x, which we substituted in the equation will give us the equation has true. But in the case of a linear equation in two variables, it need not be the case. Suppose if k is 77, then p is 1. So Virat Kohli has made 77 runs, Pandya has made 1 run, and together they have made 78 runs. So 77 comma 1 is also a solution to the above linear equation. So a linear equation in two variables does not have a unique solution. So since this is a game of cricket, a batsman cannot score negative runs. So if there was negative runs possible, okay, we'll come back to the the negative part maybe in the next example. So in this equation, as a solution to this equation, we can thus form different combinations. For example, 3 comma 75, 8 comma 70. Okay, so uh, in this case there are a finite number of solutions, because we cannot have negative uh, what to say negative runs in cricket match. If negative runs was possible, okay, suppose if negative runs was possible in a cricket match, and suppose Virat Kohli made -1 runs. Then Hardik Pandya would have made 79 runs. And when you add them together, we get 78 runs. If negative runs was possible, then we could have infinite number of solutions, because we can have -78 runs made by Virat Kohli and one 156 runs made by Hardik Pandya, and when you add -78 plus 158, you get back 78 runs. So a linear. So we'll come back. I will get back to that part later. So right now, the point that I would like to stress is a linear equation in two variables does not have a unique solution. Okay, so now let us look at another example. The sum of two natural numbers is 70. Represent this as a linear equation and find the numbers. So let the first number be, small r. This is the variable r, and the second number will be small s. You can use any two variables. There is no requirement that you should be using only x and y. It's up to you. So what we know their sum is 70. So r plus s is 70. This is what we know, and this is the required linear equation. So how do we find these numbers? Okay, so if the first number r is 0, then s is 70. So 0 comma 70. So these are two numbers that when you add them, you get 70. If the second number is 0 and if the second number is 0 and this is r, okay, kindly read this as r, then r is equal to 70. So first number being 70 and the second number being 0, this is also a solution to the equation, because when you add them you get 70. So a standard way, a easy way of solving a linear equation in two variables is, first give the value to the first variable as 0 and find out what value the second variable takes. Here r is 0 and s takes the value 70. So we get one solution. Another easy solution is you give 0 to the value of the second variable. So here we are giving s as 0, and then find out what value the first variable takes. So we have 70 comma 0. This is also a solution to the equation. So if r is 0.1, okay, if r is 0.1, then s is 69.9. These are also two numbers which when we add, that will give us 70. So again, if r is -1, okay, so we have the question says find two numbers so that when you add them their sum is 70. So I can have -1, and if I take s to be 71, when I add them, it will give us a sum of 70. So if that is possible, then I can have -0.1 and s can be 71.1. So when I add them, I'll get it's not 71.1, it is 70.1. Kindly read this as 70.1. So when I add them, I'll get 70. So in this way we can have infinite number of solutions. So a linear equation in two variables has infinite number of solutions. So I hope we are clear with that. See, for example, if I have 10, if I have -10 here, I'll have s as 80. So there is no limit to the number of solutions that we can make. All we have to do is give some value to the first variable and then find the corresponding value of second variable, and this can be, we can keep on giving as many as number of values to the first variable and find the value of the second variable. So a linear equation in two variables has infinite number of solutions. Thank you.